Good morning, children. In our previous session, we discussed about the terms related to lens. They are center of curvature, radius of curvature, optic center, principal axis, focus, and focal length. These are the terms we already discussed in our earlier classes. Today, we are going to learn images formed by a concave and convex lens. Right. So before going to learn that, let us learn basic ray diagrams. What, Nana? Basic ray diagrams. Okay. Are you ready? Yes. Then move to our physics lab. Here we go. First basic ray diagram is when the light ray is parallel to principal axis, after refraction it passes through focus. See here, this is the light ray which is parallel to the principal axis. So after refraction it is passing through focus. Clear? So this is the first basic ray diagram. Now let us see the second basic ray diagram. The second basic ray diagram is if the light passes through focus, after refraction, it becomes parallel to the principal axis. See here. So this is the light ray which is passing through the focus. So after refraction, it becomes parallel to the principal axis. So this is the second basic ray diagram. Now coming to the third basic ray diagram, if the light ray passes through optic center, it is undeviated. That means no refraction takes place. See here. So this is the light ray which is passing through the optic center. So then there is no refraction. No refraction takes place. It is undeviated. Means it is going in its original path without refracting. So these are the three basic ray diagrams we should learn to trace any image. Okay. Now let us see how the convex lens is going to form image for different positions of the object. So first let us keep the object is beyond the center of curvature. This 2F represents center of curvature. Okay. When the object is beyond the center of curvature, let us see where the image is going to form. For this I have taken an object, a candle. Okay. So the height of the candle I am taking as for better visualization of the height of the object, I am taking the height as the two boxes. That's why I have given a grid at the background of the experiment, so that I am taking the size of the object as two boxes. If you consider one box is 1 centimeter, then the height of the object is 2 centimeter. Now let us see when the object is beyond center of curvature, where it is going to form image. So to trace any object image, how many number of light rays are required? Then minimum number of light rays required are 2. Already we learnt. So I am taking one light ray which is parallel to the principal axis, so that after refraction it is passing through focus. Second light ray I am taking which is passing through the optic center. It is undeviated. Now observe carefully. The two refracted light rays are meeting at a point, at this point. Okay. So that means the top of the object is going to form image at this point. Clear? So now see that image. Where is the image? The location of the image is between 2F and F. Now let us write down the nature and position of the image formed by the convex lens when the object is beyond 2F. Okay. When the object is beyond 2F, the image formed by the convex lens is inverted image, and it is a real image because the refracted light rays are really meeting at this point. So the image formed is real image, and it is diminished. See the size of the object and the size of the image. The size of the image is less compared to the size of the object, so that we can say the image is diminished and it is inverted. It is inverted. So these are the characteristics of the image. Now what I am doing is I am moving the object towards the lens. So now the object I kept at center of curvature. Okay, so means 2f, at a distance of 2f from the optic center I placed. See where the image is going to form. Image is going to form on 2f again. Clear, sir? Now you observe the characteristic of the image formed by the object. So the object height of the object, here it is 2 boxes, means 2 centimeter. Here also it is 2 centimeter, means the height of the object is same as height of the image, and the image is real inverted image. Is it magnified? No. Okay, because the size of the object and the size of the image is same. Okay, right. Now let us see where is the lens is going to form image when the object is placed somewhere between 2f and f. Okay, now see that the image formed beyond 2f, the image formed beyond center of curvature, and observe the image. Now the image is magnified. Okay, compared to the height of the object, the height of the image is greater. So then we can say the image is magnified. What is its nature, sir? Is it real image or virtual image? Real image, because really the light rays are meeting. So it is real, inverted and magnified, formed beyond 2f. This is the nature of the image and characteristic. Now, till you move the object towards the lens and place it on focus. Okay, then see where is the image. Image forms at infinite distance. Where is the image, sir? Image forms at infinite distance. Okay, now then what could be its nature? The nature will be again real, inverted and highly magnified image you are going to get. See, these are the refractor light rays, so they are going somewhere. Okay, now so then you will be getting highly magnified image. So that is the nature of the image. Again I am moving the object closer to the lens. Then you can see that you will be getting an image towards the object. Okay, where is the image, sir? Now same side of the object image is formed. Now is it real image or virtual image? See, these are the refractor light rays. These refractor light rays never meet because these are moving away from each other, diverging. We will be saying they are diverging, moving away. So there is no chance of forming image this side. So then when you extend back, these light rays are meeting here. So that means the light rays appear to be meeting at this point. That means it is a virtual image because the light rays are not really meeting at this point. So they appear to be meeting at this point. So this image is known as virtual image. Okay, then what is its characteristic? See that it forms a magnified image. Okay, it is magnified and virtual, and it is erect, not inverted. Okay, na erect image. Okay, so the nature of the image is erect, magnified and virtual. Clear, sir? When the object is placed between optic center and the focus. Understood? So this is how a convex lens forms image for different positions of the object. Clear, Nana? Now you observe carefully. When the object is moving towards the lens, okay, image is moving away from the lens. Do you understand? Okay. When the object is moving towards the lens, image is moving away from the lens. Right, Nana? So this is the observation. And in the case where the object is placed between optic center and focus, we will be getting a virtual image. Clear? Very good. Now let us discuss image formed by concave lens. Okay, it is also known as diverging lens. Okay, so now see that when the object is in front of the lens, means it is somewhere beyond 2f, beyond center of curvature. Where do you get the image? As the concave lens diverges the light rays after refraction. See that if the light ray is moving through the optic center, it is undeviated. When the light ray is parallel to the principal axis, after refraction, it passes through focus. Okay, as it is diverging the light ray, if you extend the refractor light ray back, it appears to be passing through the focus. So that this is the refractor ray and this is one more refractor ray because it is coming back. So image is going to form between focus and the optic center. Okay, so wherever you place the object in front of the concave lens, image is going to form between optic center and focus only. And what is the nature of the image formed by the lens here? So it is diminished. See that it is very diminished and it is a virtual image because they are appear to be meeting at this point. It's not a really refractor ray. This is the real refractor light ray. Okay, and it is virtual and it is erect. Okay, erect, virtual and a diminished image is going to form between optic center and focus of the lens. Now let us move the object towards the lens. See, what do you observe? So this is your observation. The position of the image lies between optic center and focus only. So as the object is coming closer, the size of the image is increasing, but it is not magnified image. Always the size of the image is less than the size of the object. So this is how a concave lens is going to form image. Okay.